In this video, I'm going to go over how we solve trig equations that involve compositions. So by composition, what we mean is that the argument in here has the angle, in this case x, getting multiplied by something. So in this particular example, cosine of 3x is equal to 1/2. The angle x is getting multiplied by 3. So these are the types of equations we're going to solve here. So just like before, we've seen that we have this interval, 0 to 2 pi, so that indicates that we want all of our angles x to be in radians. So what we do, I'm going to rewrite the equation. Cosine of 3x is equal to 1/2. As we've seen in another video, what this means is cosine of what angle equals 1/2. That's the question we're trying to answer first. So when does cosine equal 1/2? If you think about the unit circle, cosine is positive in quadrant 1 and 4. So in radians, that angle is going to be pi over 3 and 5 pi over 3. If you're not sure, just double check that on a unit circle. So what we do is we take the argument 3x, and I'm going to set that equal to pi over 3. And then I'm going to take 3x, and I'm going to set that equal to 5 pi over 3. Now what we need to do for these types of equations, anytime we have a composition like this, so 3x here, what we need to do is we need to add 2k pi to each of these. Okay, so we include this general term because what's happening is, if you think back to what the graph looks like, if I have the original cosine graph, looks like that up to 2 pi. If it's cosine of 3x, what's happening is up to 2 pi, this graph gets condensed horizontally. So it's going to be something like this. Okay, and it looks like I kind of, something like that. Let me redo that. It should start up here. 1, 2, 3. So it gets condensed kind of by a factor of 3 there. So what that means is there's going to be many more instances or many more places between 0 and 2 pi that graph is equal to 1/2. So if I zoom in on this, if I put a 1/2 right here, there's going to be 1, 2, 3, 4, 5, 6 places that graph hits 1/2. So this 2k pi is accounting for that, and we'll see how. All right, so let's look at the left branch first. I'm going to divide everything by 3. I get x is equal to pi divided by 3 is the same as, pi thirds divided by 3 is the same as pi over 3 times 1/3. So this is pi over 9. And then I'm going to divide that 2 by 3. So 2/3 k pi. And I didn't say this, but k is any integer. Okay, so we've come up with a general solution. This is a general solution. We saw something like this when we were working with asymptote lines on our graphs. This was just a general solution. In other words, I can put any value of k in there, and that'll tell me when this cosine graph is going to equal 1/2. But I only want to come up with values that are between 0 and 2 pi. So that's what I'm going to check. We start with k equals 0. So I say x is equal to pi over 9 plus 2/3 times 0 times pi. And what we get is pi over 9. I'm sorry, pi over 9. And that is in this range, 0 to 2 pi. So that means this is one of the solutions. Okay, so I keep going, testing values of k. So when k is 1, I get x equals pi over 9 plus 2/3 times 1 pi. Simplifying this, well, I'm going to have pi over 9 plus 2/3 pi. I'm going to rewrite this 2/3 pi with a common denominator. It would be 6/9 pi. So pi over 9 plus 6 over 9 pi is 7 pi over 9. That's good. When k is equal to 2. So I keep going until I get an angle that is bigger than 2 pi. When k is 2, I'm going to get pi over 9 plus 2/3 times 2 times pi. This comes out to 4/3 pi, so multiplying to get a common denominator is going to be 12/9 pi. Adding that to pi over 9, I get 13 pi over 9. And that is good. Let me put, this is a little bit cluttered here. Okay, so those three work. And then if I do k is equal to 3, I'm going to get x is equal to pi over 9 plus 2/3 times 3 times pi. Oop, don't need that parenthesis. And what we see here is that 3 cancels with that 3, so I get pi over 9 plus 2 pi. Well, that is definitely bigger than 2 pi, and if I add that, that's 18, so 19 pi over 9. That is not one of the solutions because it's bigger than 2 pi. So my three solutions, let me just highlight them here, are pi over 9, 7 pi over 9, 13 pi over 9. And that is just for this first branch of the equation. So I have to do a similar thing for the second branch. Now, before I continue, one thing to notice is that oftentimes we'll see a pattern here. Pi over 9 to 7 pi over 9, I'm adding plus 6 pi over 9. Same thing, if I add 6 pi over 9, again, I get to 13 pi over 9, and then 13 pi plus 6 pi gives me this one over here. Okay, so oftentimes we'll start to see a pattern like that. All right, let's do the second branch. Okay, before I do that, I need to solve that for x. So we're going to say divide by 3. So x is equal to 5 pi over 3 divided by 3, or times 1/3. I get 5 pi over 9 plus 2/3 k pi. And then we got to test values for k. So when k is equal to 0, that's usually the easy one because that second term will go away. So x is equal to 5 pi over 9. That's good. When k is equal to 1, I get 5 pi over 9 plus 2/3 times 1 is 2/3. We already have seen that 2/3 pi is 6 pi over 9. So that's 11 pi over 9. That's good. And what we notice again is I'm adding 6 pi over 9. And that pattern is going to hold here. So when k is 2, if I add 6 pi over 9 to 11 pi over 9, I get 17 pi over 9. That's good. When k is 3, if I add 6 to the numerator, I get 23 pi over 9, which is not a solution. So my three solutions that I came up with in this branch are 5 pi over 9, 11 pi over 9, 17 pi over 9. So putting it all together, x is going to equal, and I'm going to put these in order from least to greatest. So x is going to be pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. So there are 6 solutions here. Okay. Now what I'm going to do is I'm going to actually graph this in Desmos, and you'll see how this works. So let's check this out. Where is the Desmos app? Here we go. Okay, so what I'm going to do is I'm just going to graph y equals 1/2. So that's this line here. And then I'm going to graph y equals cosine of 3x. Okay, and then I'm going to graph the line x equals 2 pi. Did it show up? Yeah, over here. All right. So what we can see is that I have all of these locations where those two graphs are intersecting. And pi over 9, 5 pi over 9, 7 pi over 9, etc. So we see those 6 values where that graph, where the curve of the cosine graph is hitting that horizontal line. Okay, so let's do a couple more examples here. This one says find all the solutions of sine of x over 2 is equal to negative root 3 over 2. And again, this is in radians. Now I said that a composition, a composition of a trig function here is when the angle is getting multiplied by something. So this is 1/2 times x. We could think of it like that. Okay, so what we want to say is when is sine equal to negative root 3 over 2? Sine is equal to negative root 3 over 2 in quadrants 3 and 4, and that's down at 4 pi over 3 and 5 pi over 3. So on the unit circle, it would be down in these positions. So 4 pi over 3, 5 pi over 3. So we're going to say sine of 1/2 x is equal to 4 pi over 3 plus 2k pi. And sine of 1/2 x is equal to 5 pi over 3 plus 2k pi. I don't need that sign. We just want the argument. Sorry about that. So 1/2 x is what each of those are equal to. Okay, so to solve both of these for x, well, let's just do the left equation. To solve this for x, I'm going to multiply by 2. So I'm going to multiply both sides by 2 here. And then we're going to have x is equal to 4/3 pi times 2 is 8/3 pi plus 4k pi. Now if k is equal to 0, we're going to get, well, x is equal to 8/3 pi. That is bigger than 2 pi, so that is not a solution. If I go k equals 1, I'm just going to get, and k equals 2, and k equals 3, and so on, I'm just going to get bigger and bigger values. But because k is an integer, it's possible that negative 1 would work. Let's check that out. X is equal to 8/3 pi plus 2 times negative 1 pi. So I get 8/3 pi minus 2 pi. And in that instance, that's going to be 8/3 pi minus 6 pi over 3. So 2 pi over 3. Is that going to work? 2 pi cosine pi over... something doesn't seem right here. Bear with me a moment. Here's my mistake. My mistake is right down here. I needed to use a 4 there. So let me make a quick change to this. So this is going to be, when k is negative 1, this is going to be plus 4 times negative 1 pi. So this should be a 4 pi, which would come out, getting a common denominator, going to be 12/3, which is negative 4 pi over 3. So that is not a solution because it's negative. It's not between 0 and 2 pi. So on this left branch, I get no solution. Let's see what happens on the right branch. Again, multiply both sides by 2. I get x is equal to 10 pi over 3 plus 4k pi. When k is equal to 0, I'm going to get 10 pi over 3, which is too big. Again, if k becomes 1, 2, 3, 4, it's just going to get bigger and bigger, so that won't work. I don't need to test bigger k values in the positive direction. But if k is negative 1, I'm going to get 10 pi over 3 plus 4 times negative 1 pi. That gives me 10 pi over 3 minus 4 pi. Well, 4 pi is 12 pi over 3, and that's negative 2 pi over 3, and that's also not a solution because it's not between 0 and 2 pi. So putting both of these together, that tells us that there is no solution here. And if you want to think about what this might look on a graph, well, that 1/2 on the sine graph, the normal sine graph would look like this up to 2 pi. But that 1/2, when I put the 1/2 in there, up to 2 pi, it's going to spread this out. It's not going to hit until, I think, 4 pi down here. Running out of space. Let's see. It's not going to hit till 4 pi. And so we want that to equal negative root 3 over 2. So it's not, we can see that in between 0 and 2 pi, that graph is never going to hit negative root 3 over 2. It's not going to hit it till over here. So that's why there is no solution on this one. All right. I think I want to just do one more in this video. So we have find all solutions. Tangent of 2 theta equals square root 3. And here we're in degrees. Okay, so we want to know when is tangent equal to square root 3 in degrees, and that occurs in quadrant 1 and quadrant 3, and that is at 60 degrees and 240 degrees. Okay, so I want, we will say 2 theta is equal to 60 degrees plus, now in this instance, instead of 2k pi, which is a full time around the circle, 2 pi in radians, I'm going to do 360 degrees times k. Okay, I'm one time around the circle in degrees is 360. So 2 theta equals 60 plus 360k, and then 2 theta equals 240 degrees plus 360k. These are usually easier for students when we have degrees as our angle. All right, so divide both sides by 2 here. I get theta is equal to 30 degrees plus 180 degrees times k. When k is 0, I get theta equals 30. That's good. That's between 0 and 360. When k is 1, I get theta equals 30 plus 180, which is 210. So that's good. When k is 2, I get theta equals 30 degrees. 2 times 180 is 360. Which is 390 degrees, which is too big. So my 2 solutions from that branch of the equation are those right there. On the other branch, divide everything by 2, I get theta is equal to 120 degrees plus 180 times k. When k is 0, we get theta equals 120. That's good. When k is 1, I get 120 degrees plus 180. Which is 300. Again, that's good. When k is 2, we get 120 degrees plus 360, which is 480 degrees, which is no good. So my 2 solutions on that branch are those guys right there. So writing it all out, I'm going to say theta is equal to 30 degrees, 120 degrees, 210 degrees, and 300 degrees. Those are all the places that tangent graph is going to hit square root 3.